Welcome to homework.
Hey everybody, so in this question we have a neutralization reaction between sulfuric acid and potassium hydroxide forming a salt and water. So we're given a few known, so I'll go ahead and write those down. We know that we have 25 mils of 0.5 molar sulfuric acid as well as 25 mils of potassium hydroxide, which is 1 molar. We also know that the starting temperature for this reaction, we'll call that T sub 0, is equal to 23.5 degrees Celsius. And the final temperature after the reaction is over is 30.17 degrees Celsius. Now the question asks us to find the change in enthalpy, so that is our delta H. With these knowns and unknowns, we can go ahead and start solving for our enthalpy change. So to do that, the first thing I'm going to do is convert our starting materials into their respective molar values. And I'm going to use these molar values to find which one of the reactants is the limiting reactant for the reaction when forming water. So for sulfuric acid, we're starting off with 25 mils, and then we're going to convert that into liters with our conversion factor, and then using the concentration that's given to us. So for 1 liter, there is 0.5 moles of sulfuric acid. That gives us a 0.0125 moles for sulfuric acid. Now going on to potassium hydroxide, we also start with 25 mils. We'll convert that to liters. So there are 1,000 milliliters in 1 liter. And we're given a concentration of 1 mole per liter. And that yields a 0.025 moles for potassium hydroxide. Now that we know that, we can go ahead and use these initial mole values to find how much water will be produced to try to determine the limiting reactant. So go ahead and do that. We have 0.0125 moles of sulfuric acid. And using our balanced equation from above, we know that for every 1 mole of sulfuric acid, it will form 2 moles of water. Working this out in the calculator, we find that 0.025 moles of water will form using that amount of sulfuric acid. Now doing the same thing, but with the potassium hydroxide. So before we calculated 0.025 moles of potassium hydroxide. And then using the balanced equation, we know for every 1 mole of potassium hydroxide, this will form 1 mole of water. And I went ahead and simplified the fraction since in the equation it was 2 over 2, and I just simplified that already to 1 over 1 since that's how the ratio worked out. So that also yields a 0.025 moles of H2O. Since both of them yielded the same amount of water, we can say that both of these will yield 0.25 mils of H2O, and we can use this value when we're calculating our heat. So moving on, we can go ahead and use our heat equation to calculate the heat absorbed by the calorimeter. To do that, we'll use our equation Q for the calorimeter is equal to mc delta T, where m is our mass, c is the heat capacity, and delta T is the change in temperature. We have all of those values. So for the mass, I'm going to use the total volume. So we started off with 25 mils of both of each reactant. So that gives me a total of 50 mils of water produced. And I'm going to go ahead and multiply this by the density of water. So that is 1 gram per 1 milliliter. And that will yield my mass. From the textbook, we know that the heat capacity is 4.184 joules per grams degrees Celsius. And the change of temperature, I'll go ahead and write in the second line since I'm running out of room, is the final minus the initial. So we have the final temperature, 30.17 degrees, and we're going to subtract that from 23.5. Plugging all of this into the calculator, we find that the Q absorbed by the calorimeter is 1,395 joules. And this is the same thing as saying 1.395 kilojoules. Now that we know that the heat from the calorimeter is this, we can say that the heat for the reaction is the negative of the heat absorbed from the calorimeter, since the reaction is releasing heat. So this is negative 1.395 kilojoules. And using this number, we can finally find our change in enthalpy. So delta H is equal to our heat that we just calculated, negative 1.395 kilojoules. And we're going to divide that by the moles that we calculated above for water. So that is 0.025 moles of water. Plugging that into the calculator, we find that the enthalpy change, is negative 55.8 kilojoules per mole H2O. And that is our final answer.